So this lesson is over algebra. So this is multiple representations, part 2. This is a graph. This graph is about bicycle travels. It's about the number of hours traveled, and distance traveled in kilometer. So we have a graph. I would like to transfer the information from this graph onto this table. So from I can tell 1 hour of traveling on a bike nets you 15 kilometers of distance. 3 hours on a bicycle has 45-kilometer distance traveled. 5 hours has a distance of 75-kilometer traveled. 6 hours on a bicycle will give you 90 kilometer of distance traveled. So what is the relationship between the distance traveled and the number of hours? Is it additive or multiplicative? If it's additive, then I would have to add 14, 14, 14, 14. That doesn't work. So I believe it is multiplicative. I have to multiply by the number of hours by 15 to find the distance traveled, because 6 times 15 is 90. So the equation is x times 15 equals y. I have to multiply the 15 by the number hour. And what variable do I see right here? X. So x times 15 equals y. Or it could be y equals 15 times x, or y equals 15x. Even though this is not part of it, I would like to answer this part. Which side is the dependent side and which side is the independent? Well, if you remember, let's see, which statement makes sense to you? Does the number of hours depend on the distance traveled, or does this make sense? The distance traveled depends on how many hours you're on a bike. The second one makes sense. So this must be the dependent, this must be the independent. This must be the dependent, and this must be the independent. For those who do not understand that and cannot understand this, I'll be honest, I'm not good at that. I have to use what the 6th grade science teacher uses at McMean, called dry mix. If you manipulate the independent, then the dependent will respond to it. So now that we understand that, last video we did perimeter train. So now we're going to do real world situations where you will have to create a table, a graph, find the equation using the relationship. Which side is dependent, independent. So each situation below gives 2 values of a relationship. Answer on a table, on a graph, and as an equation. Then write as a summary to make a prediction. Owen was 3 years old when his sister Greta was born. So when Greta was born, 0, he is 3 years old. When Greta is 1 year old, that means he's 3 years older, so he's 4 years old. When Greta is 2, Owen must be 5. When Greta is 3, Owen must be 6. When Greta is 4, he must be 7. When Greta is 5, he must be 8, because he is 3 years older than his sister, Greta. So which side is the dependent and which side is the independent? Does Greta's age depends on Owen's age? Or does Owen's age, to find Owen's age, it depends on what Greta's age is? The second statement makes sense. So this must be the dependent, and this must be the independent. The dependent is Owen's age, and the independent must be Greta's age. Write an equation using the relationship of Greta's age to Owen's age. Let me use a different pen color. I'll use blue for this one. Is the relationship multiplicative or additive? Well, I can't multiply anything by 0 to get 3, so it must be plus 3 plus 3. Think about it. In a real world situation, it said he is 3 years older. I mean, like you add 3. So it's x plus 3 equals y, or y equals x plus 3. Because you're adding 3 to Greta's age to find Owen's age. Now let's create a table. So they say the x-axis is this is Greta's age, and this is Owen's age. So when Greta is 0, Owen is 3. When Greta is 1, he is 4. When Greta is 2, 5, 6. So in this one, would this be continuous or would it be discrete? Continuous means connect dots, or would it be discrete? It's just these dots. Let's think about it. Can you be a fraction, a decimal of an age? Yes, you can. Yes, you can be 1 year, 1 day. So we connect the dots. So the relationship is additive. Make a prediction. If Greta is 76 years old, Owen will be 3 years older, 79. Because x plus 3 equals y, and 76 plus 3 equals 79. Last but not, our next one. On average, it takes 4 minutes to complete each math problem. So if you work for 0 minutes, you will definitely do 0 problems. If you work on 1 problem, it will take you 4 minutes. If you work on 2 problems, it will take you 8 minutes. 3 problems, 12 minutes. 4 problems, 16 minutes. 5 problems, 20 minutes. It takes 4 minutes to complete each math problem. Which side is a dependent, independent? All right, let's think about it. Does the number of problems depends on how many minutes? Or does to find the minutes, it depends on how many problems you're working with? The second statement makes sense. So this is dependent. The dependent is the minutes, and this is the number. Independent is number of problems. Write an equation finding the relationship between the minutes and the number of problems. Well, it can't be additive because 0 plus something is 0. So it must be multiplicative times 4 times 4 times 4 times 4. So it's x times 4 equals y, or y equals 4x, or y equals 4 times x. Now let's graph it. X-axis is the number of problems, number of math problems, and this must be the minute. So if you're working on 0 problem, it take you 0 minutes because you're not working on it. 1 minute takes about 1 problem takes about 4 minutes. 2 problems take about 8 minutes. 3 problems take about 12 minutes. Even though we can't graph it, 4 problems will take about 16 minutes. So it's multiplicative. Is it continuous or discrete? Do we connect it or not? Well, think about it. Can we do like one in a decimal 1.0001 problem? No, that doesn't even make sense. A fractional or decimal of a problem? No. So it is discrete. Discrete is just one singular thing, one event. So make a prediction. It took you 60 minutes to complete the math. So it took you 60 minutes to complete the math assignment. How many problems did you complete with? So let's go back to our table. If it took me 60 minutes, what's the relationship between 20 minutes to 60 minutes? Times 3. Times 3. So 5 times 3, it'll be 15 problems. Another way to do it is 60 equals 4 times what is 60? 15. And if you need just a little more practice, we could practice one more. Here is a table. What is the relationship here between Tim's age and Jill's age? Is it multiplying or adding? I believe it's adding 15. So write an equation, y equal x plus 15. Which one is independent? To find Jill's age, it depends on Tim's age. So the independent Tim's age. When Tim is 60, how old will Jill be? 15 more would be 75 because Jill is 15 years older than Tim. So, right verbal. Jill is 15 years older than Tim. But this is multiple representation part 2.